And we are continuing Chapter 6. We're going to be doing Lesson 3, so 6.3, Approximating Square Roots. So the key ideas for this lesson, we are going to be looking at types of numbers. So we've got rational numbers, and those are numbers that can be written as a ratio of two integers. Irrational numbers, and those are numbers that cannot be written as the ratio of two integers. So the square root of any whole number that is not a perfect square is irrational, and the decimal form of an irrational number neither terminates nor repeats. So those are some things to remember about irrational numbers. And then we've got real numbers, and these are sets of numbers that include rational numbers and irrational numbers together. So if you look at the circles here, so together you've got real numbers, and then in blue are your irrational numbers. So the square root of 2, negative 2 pi, the negative square root of 3 pi, those are all going to be irrational numbers. Rational numbers, remember, those are the numbers that can be written as ratios of two integers. So 1 over 2, negative 2/3, 2.25, and then 0.3 repeating. Integers are those negative numbers, so negative 1, negative 2, negative 3, and the natural numbers are going to be your positive numbers, 1, 2, 3. So those are going to be the numbers that we're going to be dealing with today. Okay, so looking at real numbers, rational and irrational numbers. I'm going to be going over some examples that you will potentially be seeing on your homework. So make sure you're taking notes that you can use with your homework and on your test. And if you have any questions, let me know tomorrow when we meet for class. And we'll go ahead and get started. So the first thing we want to look at is how to classify real numbers. So real numbers are classified as irrational and rational. So if you've got the square root of 12, this is an irrational number. And it is irrational because 12 is not a perfect square. Okay, it cannot be a perfect square. Negative 0.364 with the 4 repeating, that is a rational number because it is a repeating decimal. Okay, so if you've got that repeating sign, you have a repeating decimal, and those are rational. Negative 1 3/7, that is a rational number. And it is rational because negative 1 3/7 can be written as negative 10 over 7. And then 0.85 is a rational number, and it can be written as 17 over 20. So that is looking at how to classify real numbers, either rational or irrational. Okay, and the next thing that we're going to be looking at is approximating square roots. So the problem wants us to estimate the square root of 52 to the nearest integer. So on a number line, figuring out what are the we're using a number line and the square roots of perfect squares nearest to this negative, or the square root of 52. So if we have the square root of 49 is 7, and then the square root of 64 is 8. So those are going to be the closest perfect squares that we would be dealing with that square root of 52. So square root of 52 on a number line is going to end up being closer to the square root of 49. So when you graph that on a number line, so because 52 is closer to 49 than 64, the square root of 52 is closer to 7 than to 8. So the square root of 52 is about 7. All right, the next thing that we're going to look at is comparing real numbers. So A wants to know which is greater, the square root of 5 or 2 3/4. So we have our number line, and our number line has the perfect square of the square root of 4 and then our square root of 9. So we've got 2 and 3. So graphing these two numbers, square root of 5 is going to be closer to the square root of 4 than the square root of 9. And then looking at 2 3/4, if you wrote that as a decimal, it would be 2.75, and that's going to be closer to 3 than to 2. So when we look at both of these and we want to figure out which one is greater, obviously the one that is closer to, that is further on the right is the bigger number. So 2 3/4 is greater. And then B is wanting to know again which is greater, 0.6 repeating or the square root of 0.36. So again, we've got our number line, and this time we're doing our number line 0.6 and 0.7, because our square root of 0.36 is going to be 0.6, which is right there on our number line, and then 0.6 repeating is going to be closer to that 7. So once again, that the number that is going to be further on the right of your number line is the greater number. And so for letter B, 0.6 repeating is greater. And that's comparing real numbers. Last, we're going to be looking at approximating an expression. So our problem states the radius of a circle with area A is approximately the square root of A divided by 3. So the area of a circular mouse pad is 51 inches squared, and it wants us to estimate its radius. So we take this equation, the square root of A divided by 3. So we know that area for this problem is 51. So the square root of 51 divided by 3. And 51 divided by 3 is 17. So we're looking for an estimate of the square root of 17 for our radius. So on our number line, we figure out those perfect squares that we can work with. So the square root of 16 is 4, and the square root of 25 is 5. So our square root of 17 is going to be closer to the square root of 16 than the square root of 25. So our radius on this problem is about 4 inches. And that's how we approximate an expression using square roots. Remember, if you have any questions, you can let me know tomorrow in class. Go ahead and be working on your own questions, and I will see you in class tomorrow to go over those questions. And then we will be working on our assignment as well. So I will see you tomorrow. Have a good day.